So right here, Jam asked a question. Jam says that in 1999, they said 2-methyl-prop-1-ene is an isomer of option A, but-2-ene option B, pent-1-ene option C, 2-methyl-but-2-ene and option D, 2-methyl-but-1-ene, right? So an isomer means you have the same number of molecules, you have the same molecular formula. So the first thing is I will use a short method to do this, and I will consider a very long method to doing this. Not a very long method, but a more workable approach. But this approach I'll first use is a very short method I would recommend in the exam hall. So you have, Jam is asking for 2-methyl-prop-1-ene. Yeah. So what you just say is the methyl, how many carbon atoms are there? We know it's just one carbon. Plus the prop, how many carbon atoms are there? We know it is 3 carbons. So it gives a total of 4 carbons. So most likely, what we are looking for is a compound that has just 4 carbons without necessarily complicating it with the hydrogen. So if you look at option A is but-2-ene. You can see it has but, and but here means 4 carbons. Option B is pent-1-ene. You can see it as pent, and pent means 5 carbons. Option C is 2-methyl-but-2-ene. So we can see that this methyl means 1 carbon, and the but means 4 carbon. So if you add these two together, it gives you a total of 5 carbon. And right here, we could see that we have on option D, 2-methyl-but-1-ene. So we could see that the methyl is also 1 carbon and the but is 4 carbon. So this gives us a total of how many carbon now? 5 carbon. So the only one that works with 4 carbons, like the methyl, this compound here, it has 4 carbon, is option A, which is but-2-ene. Our answer goes to option A. But say you want to solve it, and then probably you have in your options 2 compounds that have 4 carbon and you want to be sure. What you just have to do is to draw out the 2-methyl-prop-1-ene. So to draw out 2-methyl-prop-1-ene, I would have to draw the prop first. So the prop should be 1, 2, 3. Prop is 3 carbon atoms. After drawing the props, I have to put the ene, which is on the first carbon. It's always on the first carbon anyways. So the ene is always for the prop. It should always be on the first carbon because there's no prop 2-ene. So 2-methyl means I'm attaching the methyl to the second carbon. So this right here is the methyl. So I've done that. So what I do is to fill the other spaces not filled with hydrogen. So you can see this carbon has just 1 bond. So I filled with 3 hydrogen to complete 1, 2, 3, 4. This carbon in the middle has 1, 2, 3, 4 already. There's nothing to put again since it's already tetravalent. And this carbon at the end has 1, 2. So to complete it as 4, I put 2 hydrogens. So let's draw but-2-ene. But-2-ene contains 4 carbon because it's a but. And 2-ene means the double bond is in the middle. So I put the double bond in the middle. So I filled, because there's nothing else, so I fill the other spaces with hydrogen. This is 1, I complete it as 3. This is 1, I complete it as 3. But this carbon has 1, 2, 3. So I just put 1 hydrogen. This carbon has 1, 2, 3. So 1 hydrogen. So this is but-2-ene. So the next person we're working with in option B is pent-1-ene. So pent is 5 carbons. So I have 1, 2, 3, 4, 5. The 1 means it's on the first, or like this. So work a bit faster now, because I think we all understand what we are working with. So here should be 2 hydrogens, and here should be 2 hydrogens to make it 4. Yeah. So this is 2-methyl-but-2-ene. So I consider the but first. So 1, 2, 3, 4. But-2-ene means the double bond is in the middle. So we have this. So the 2-methyl means the CH3, the methyl, comes to the second. So this is already complete. This remains 3. This remains 3. And this remains 1, right? So let's draw the last one, which is 2-methyl-but-1-ene. Still the same but. 1, 2, 3, 4. But this time the double bond is on the first carbon, and the methyl is still on the second carbon. Prefill, fill. So this second carbon is filled up because it's 1, 2, 3, 4. So this one needs 2 more. Right? This one needs 2 more. And this one needs 3 more because it's just 1. So it needs 3 more. So the last thing to do is to count how many carbons and hydrogen are in the original 2-methyl prop 1 in that we are comparing to the options. So we have 1, 2, 3, 4 carbons. And the amount of hydrogen is 2 plus 3, which is 5, plus 3, which is 8. So what we are looking for is a compound that also have 4 carbons and 8 hydrogens. So let's go. 1, 2, 3, 4. So that's 4 carbons. And 3 plus 3, 6, 7, 8. 8 hydrogens. Quite straightforward, right? But let's look at the others. This is 1, 2, 3, 4, 5. So this is having 5 carbons. That makes it wrong already. If you count 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. That makes it wrong. Then this is 1, 2, 3, 4, 5. 5 carbons. Then the hydrogen is 3 plus 3, 6, plus on that 3, 9, plus 1 more, which is 10. Here you have 1, 2, 3, 4, 5 carbons. So the hydrogens are 2, 5, 6, 7, 8, 9, 10. So we can see the only one that works for that compound there is both 2 in, which is option E right here. Option E. Thank you.